There are hundreds of thousands, if not millions, of archaeological sites left to find around the world. And the only way to find all these sites is using new technologies that allow us to pinpoint where we've lived and help us better understand how we've lived.
Have you ever wondered if those faint, fleeting streaks captured in satellite images of the Egyptian desert back in 2011 were merely technical glitches? Or if they were the final traces of something that chose to lie dormant for millennia? Sarah Parcak, the archaeologist who used infrared technology to peel back the layers of the earth, sat alone in a dark room, piecing together those nameless, reflective spots. To her astonishment, she discovered that beneath the blanket of desert sand were dozens of structures that humanity thought should only exist above ground. But there they were, silent, waiting. What mystery forced Sarah Parcak to withstand such pressure and keep it a secret, and what is the truth that has been hidden from us all this time? We will reveal the answer in this video. Every story we uncover brings us closer to the ancient world and those who shaped it. Your support through a like, share, or subscribe helps keep this exploration alive. The Archaeologist, Excavating from Space. In the southern sky above Egypt, the first images began to stream from a NASA satellite. Beneath the layers of sand stretching to the horizon, unusual dark patches appeared: triangles, squares, or parallel lines cutting across a region thought to be nothing but wind and rock. In her office at the University of Alabama in Birmingham, Sarah Parcak zoomed in on the details, her eyes stopping at a tiny spot near the Sahara Desert where the landscape showed oddly regular patterns, the distinct traces of artificial construction. Sarah Parcak is an archaeologist who specializes in satellite remote sensing. She calls her work excavating from space. Instead of carrying a shovel and a brush, she uses infrared data to detect anomalies in the soil structure. Each region of land has a different light reflectivity, and when something is buried beneath it, such as mud brick or stone walls, it causes a subtle shift in the infrared wavelength. By reading these minute variations, she can detect the traces of ancient structures hidden meters below the surface. Previously, this method was rarely applied on a large scale for Egyptian archaeology. Traditional excavations focused on known areas: Giza, Luxor, or the Valley of the Kings. But Sarah realized that most of Egypt had never been surveyed. She estimated that what humanity had unearthed accounted for less than 1% of the remaining archaeological sites. The idea of using satellites to see through the sand began from there. In 2011, a joint project between NASA and the University of Alabama was initiated. The goal was to scan the entire Nile Delta area using multispectral satellite imagery, including the infrared band. The raw data was processed using a geophysical pattern recognition algorithm, filtering out areas with unusual material density. Each bright pixel in the image was a point of inquiry. After months of processing, Sarah's team obtained the first map, a dense layer of red markers scattered across the country. Among them, a particular cluster emerged on the periphery of Saqqara. When zoomed in, small triangles appeared, possessing a regular, symmetrical structure, all oriented toward the same bearing. She demarcated the area, overlaid it with an ancient topographical map. The location was situated a few kilometers from the Djoser Pyramid Complex. Sarah marked the screen with 3 short words: possible pyramids. In the following days, the research team cross-referenced the data with other sources' radar images, historical maps, and 19th century archaeological records. Many locations did not coincide with any known structures. The map gradually revealed 17 areas with geometric features similar to pyramids, along with over 1,000 suspected tombs and chapter 3,000 vestiges of buried settlements. When the information was publicized, the press called Sarah Parcak the space archaeologist. Images of her in the control room, holding a printout of the infrared image, appeared on the covers of many scientific journals. The research community acknowledged this as a new milestone in the understanding of Egyptian archaeology, a place where the desert was not only dug by hand, but also scanned with data from space. For Sarah, every image is a cross-section of history. As the satellite system sweeps over, the light reflected from the sand and rock is encoded into numbers, then converted into a 2-dimensional image. In the simulated color spectrum, areas with buried structures always show up with a distinct shade. To the naked eye, one only sees an empty patch of sand, but on the screen, those are strangely precise geometric shapes. Her work demands patience. Thousands of images are downloaded, and each one needs to be processed, cross-referenced, and then verified. Every small trace in the image could be an ancient stone block, or just a deviation caused by light. She often worked through the night, comparing frame by frame, making notes with symbols, and marking noteworthy regions as the data accumulated. The small, scattered dots began to form a network, the pattern of a submerged civilization. Her colleagues recounted that Sarah would often remain silent for a long time before saving an image. She would observe the interconnected straight lines, then quietly say, "This might be something." From that moment, the verification process would begin. The team would send the coordinates to archaeological missions in Cairo, requesting an on-site inspection. Everything proceeded according to strict scientific protocol. The first few months of the project passed in silence. Most results matched known sites, but the Saqqara map continued to preoccupy Sarah. In the nighttime infrared sensor images, the dark blocks appeared clearer, with sharp boundaries, pointed angles, and estimated height-to-base ratios close to those of small-sized pyramid structures. She decided to make a preliminary announcement of the findings, adding the caveat that they were only potential possibilities. From that moment, Sarah's project began to draw international media attention. Articles continuously appeared discussing Egypt's 17 lost pyramids in her office. She continued to check the data, adjusting every image filter, trying to determine whether those shapes were truly artificial structures or just an illusion caused by light and dust. 17 pyramids under the desert. The first map was printed on a large format, covering the desert surface with thousands of small dots, in Sarah Parcak's laboratory. The white light reflecting off the map turned the infrared signs into mottled gray areas, resembling a photograph of the moon. Each faint mark represented a subterranean anomaly, but 17 points scattered across Middle and Lower Egypt were distinctly triangular. They were not strictly aligned, but they shared the same north-south orientation as the ancient pyramids. Sarah's team dubbed it the Map of Shadows. The name originated from how the buried structures reflect infrared light weaker than the surrounding soil, creating dark areas akin to an object's shadow. In the satellite images, they appeared uneven, sometimes just a faint right angle, sometimes a complete triangle. The contrast of these areas allowed the computer to recognize them as a repeated pattern sequence, exactly matching the typical proportions of Old Kingdom pyramids. For confirmation, Sarah cross-referenced with ancient maps drawn by French archaeological teams in the 19th century and topographical data from the Egyptian Institute of Archaeology. No structures were recorded at those coordinates. The traces were located in the Saqqara, Tanis, and Fayum areas, places that were once ancient necropolises or religious centers. The more the team scrutinized the data, the more they realized the dark areas had a consistent base elevation, clearly different from the surrounding sand. This suggested the existence of a foundation or an artificial masonry structure beneath. One of the most prominent spots was located near the west bank of the Nile. Nighttime infrared images showed the triangular shape more sharply as the desert temperature dropped. Sand cools quickly, while rock retains heat longer, causing the area with artificial material to emit a stronger thermal signal. Multispectral analysis confirmed that the area contained a mineral density and composition similar to limestone, a material commonly used in pyramid architecture. The information quickly spread beyond the research scope. The BBC and CNN reached out for interviews. Newspapers ran large headlines. NASA satellites reveal 17 lost pyramids. The magnified satellite images, annotated with red arrows, circulated internationally to the public. The number 17 made a strong impression. To Sarah, it was simply 17 coordinates potentially containing artificial structures. She repeatedly stressed that. Satellite data indicate possibilities, not certainties. In the office, she and her colleagues reviewed the entire data processing procedure. Every filter, every light parameter was checked. The images were taken at various times of the day to eliminate the factor of natural shadow. Small discrepancies were corrected by comparing them with known structures like the Djoser or Sneferu pyramids, where the reflective properties had been accurately measured. After cross-referencing, the 17 points still retained their geometric characteristics. When the team presented the results at a symposium in Cairo, the initial reaction was silence. Traditional archaeologists sat quietly before the two-dimensional images Sarah projected. for them. A structure was only real when seen with the eye or touched with a hand, but the infrared images suggested a different reality, a deeper layer that humans had not reached. Some asked about the margin of error, about the possibility of confusion with natural phenomena. Sarah answered each question, citing the methods and processing algorithms. She presented the data as a scientific report, not a discovery claim. In the following weeks, a local survey team was sent to Saqqara for ground verification. They conducted test excavations at one of the marked locations, beneath the fine sand. They found signs of mud brick and square-cut stone fragments, proving that a structure once existed there. This discovery drew even more attention to Sarah's project. The press called her the woman who can see through the desert. As more people learned about it, the volume of data sent back to the lab grew. Other scientific organizations wanted to apply similar methods to Syria, Iraq, and even Central America. For Sarah, the project in Egypt remained the focus. She spent hours reviewing old images, looking for connections between the dark spots on the map. A pattern began to form. The hypothesized pyramids seemed to lie along ancient routes, connecting administrative centers of the Old Kingdom. Her map, when overlaid on an ancient map of the Nile, suggested these structures might have been ritual stations or boundary markers. Many other areas showed similar, but weaker signs. Each point was coded with a symbol, numbered, and saved into the database. When completed, it was a map of thousands of locations, not a treasure map, but a map of buried memory. In the final composite image, the 17 geometric structures appeared against the gray background of the desert. There were no clear lines, only blurry shapes reflected through multiple wave bands. Sarah stepped back, looking at the entire map stretched out before her. She knew it was not just a research tool, but a clue leading to a part of Egyptian history that had never been documented. When the world cannot accept. When Sarah Parcak's map appeared in international newspapers, the reaction from Egypt was immediate. The Ministry of Antiquities office in Cairo issued a statement asserting, "No new pyramids have been discovered." This brief response, signed by Zahi Hawass, who was the Minister of Antiquities at the time, virtually shut down all ongoing, fervent discussion. In his eyes, satellite data could not replace on-site archaeology. For those who had dedicated their lives to traditional excavation work, infrared images were nothing more than hypotheses. Within a few days, local newspapers began to raise questions. Some labeled Parcak's findings an over-technological illusion, while others suspected the data was misinterpreted due to weather phenomena. Sarah did not react immediately. She took time to review all the results with her research team. On the computer screen, the infrared triangles were as clear as before. Every measurement, every coordinate matched the original data. There was no sign of error in the processing procedure. Online, two streams of opinion formed. One side supported Parcak's new approach, viewing it as a step forward that would expand the scope of research. The other argued that science could not rely on images to draw conclusions about archaeological structures. Discussions among experts on professional forums debated the accuracy of satellite imagery and the possibility of mistaking man-made structures for natural geological phenomena. Each opinion was backed by evidence, but no one had enough data for a definitive conclusion. While the debate unfolded, the survey team at Saqqara temporarily halted their work. Excavation permits were reviewed, and access to the area was restricted. The samples already collected were moved to storage. Sarah continued to work in the lab, focusing on analyzing data from other regions. She chose to remain silent, letting the results speak for themselves. For her, numbers are devoid of emotion. They are either correct or incorrect. At a scientific conference in London, Parcak re-presented the research process. She did not talk about pyramids, but only about infrared reflectance anomalies suggestive of artificial structures. Her voice was steady, without emphasis on any particular section. Researchers in the auditorium listened in silence. A few asked about the burial depth of these structures and the possibility of them being created by modern activities. Sarah opened the data slides, pointing to each spectral layer, each thermal band, and each reflectance parameter. Every answer was brief, based on measured facts, without adding speculation. During the same period, many other scientific organizations began testing similar methods in different countries. Initial results showed that infrared data could quite accurately identify buried structures. This indirectly reinforced the direction Sarah had chosen, even though the controversy surrounding the pyramids had not cooled down. In Birmingham, her laboratory continued to operate normally. Every day, new satellite data was downloaded, processed, and archived on her desk. The Saqqara map still hung in its original position. With 17 red markers, she neither removed them nor added any more. Occasionally, students would ask about the excavation progress. She would simply answer, "Nothing new yet." For Sarah, science always progresses slower than public opinion. What the public calls a discovery is merely a starting point for verification to a researcher. She once said in an interview that, "The satellite doesn't create the story, it only points the way." That quote later appeared in many articles, serving as a simple explanation for a multi-year controversy. Some young Egyptian archaeologists began to re-examine her data. They used the soil temperature maps, re-measured the reflectance, and found small overlaps with the original results. This data was not officially published, but gradually spread within the professional community. Many began to acknowledge that satellite technology held real value in site detection, even if it could not precisely determine scale or age. Under the white light in the lab, Sarah still sat before the screen, observing the magnified patches of desert. The faint lines and regions of light and dark remained just as they were on the first day. To her, they were data, but also evidence of a possibility the world was not yet ready to accept. Seeking the truth beneath the sand. Years passed since the map of the 17 buried pyramids appeared in the media. Various archaeological projects were carried out in Egypt, but no official report confirmed the existence of those structures. A few independent research teams went to Saqqara and Tanis, using ground-penetrating equipment, and the results showed signs of brick walls and stone foundations, but not enough data to confirm they were pyramids. The data remained on the table, awaiting a final conclusion. Sarah Parcak continued to teach at the University of Alabama and maintained her global observation lab. She expanded her research to many other countries: Peru, Romania, Jordan. New maps emerged, showing countless previously undocumented sites. The technology she pioneered became a common tool in modern archaeology. Museums and international organizations began establishing satellite databases for heritage preservation, partly thanks to the foundations Sarah's project had built. In her scientific talks, she often showed the image of the Egyptian desert as the first example. The old infrared photo appeared on the screen, faint dark blocks against the sand background. She no longer mentioned the number 17, nor did she emphasize the aspect of missing pyramids. Instead, she talked about the potential of technology to help humanity better understand the past. She pointed out how small changes in soil structure can reveal an entire civilization. On one occasion, in a speech at a conference on digital archaeology, Sarah said that only about 1% of Egypt's surface area had ever been excavated. That number silenced many in the room. She explained that this was not due to a lack of manpower or resources, but because most sites remained deep under the sand, where people did not know where to look. With satellite technology, we can see the remaining 99%, the faint traces that time has not completely erased. Her work gradually became a form of continuous observation. New satellite data is downloaded every week, overlaid onto the old maps. Areas that appeared faintly in 2011 are now clearer thanks to higher resolution. Some of these points coincide with the locations of newly confirmed sites through ground surveys. Sarah marks them again, adding the annotation, "Verified Anomaly." These quiet notes gradually prove that her method has merit. When asked about the old map, she only said it was a part of the journey toward understanding. For her, research is not about asserting who is right or wrong. It is the process of observing what is hidden beneath the surface and asking why it is there. Every anomaly, every patch of differently colored ground, is a signal. The story does not end with the map. It begins with the data itself. Many people call her the one who sees the past from the sky. The phrase appeared in scientific journals and documentaries about modern archaeology. Sarah did not comment, but in her lectures, she always reminded students that every discovery, no matter how small, needs to be verified. Science is not a declaration, but the patience of those who are willing to wait for the evidence. In recent years, data from new satellite projects continues to show hundreds of similar signs along the Nile Delta region. Some of these coincide with the locations previously marked by Sarah's team. Young archaeologists continue the work, using more advanced technology for verification. No one calls them missing pyramids anymore, but everyone acknowledges that the 2011 images opened up a new direction. In a final filming session for a documentary, Sarah sat in front of a screen displaying the map of Egypt. Lines of light moved slowly, simulating the satellite orbit. She spoke about the role of technology in preserving human memory. The image switched to a close-up, where the faint triangular shapes on the map were still there, unchanged after more than a decade. The background sound was the wind blowing over the desert, steady and sustained. The faint shapes on the map remained still, like the remaining part of a story yet to be fully told. This information is compiled in good faith and with respect for ancient civilizations, if any errors are present. We are prepared to correct them upon receiving reliable academic feedback. We are not responsible if you misunderstand or misapply this content.